సో బ్లోఫిష్ అల్గారిథమ్స్. సో బ్లోఫిష్ అల్గారిథమ్స్ అంటే ఫస్ట్ మనం గుర్తు రావాల్సింది ఏంటిదంటే ఇది ఎట్లాంటి సైఫర్ అనేది అంటే ఇట్ ఈస్ 64-bit బ్లాక్ సైఫర్ అల్గారిథమ్ అనమాట. అంటే ద ఇన్పుట్ ఆర్ ద ప్లెయిన్ టెక్స్ట్ ఈస్ కన్సిస్ట్ ఆఫ్ 64 bits. ఇట్ ఈస్ మోర్ సెక్యూర్ బికాస్ ఆఫ్ ద వేరియబుల్ కీ లెంత్. ఇందులో మన కీ సైజ్ అనేది ఫిక్స్డ్ ఉండదు అనమాట. వీ హ్యావ్ ద కీ సైజ్ అప్ టు 32, మినిమం 32 ఉండాలి, మ్యాక్సిమం 448 ఉండొచ్చు. తర్వాత ఇక్కడ ఏంటిది సిమెట్రిక్ కీ. ఇప్పుడు నాకు గుర్తు రావాల్సింది బ్లోఫిష్ అనగానే సిమెట్రిక్ కీ అంటే ఎంక్రిప్షన్కి డిక్రిప్షన్కి రెండింటికి మనకి కీ అవసరం. ఓకే, సిమెట్రిక్ కీ వేరియబుల్ లెంత్ సిమెట్రిక్ ఉండాలి, వేరియబుల్ లెంత్ ఉండాలి, అండ్ ద ఇన్పుట్ షుడ్ బి 64-bit. ఇట్ ఈస్ ఫాస్ట్ అండ్ ఫ్రీ ఆల్టర్నేటివ్ టు DES అండ్ IDEA. దానికి ఫ్రీ ఆల్టర్నేటివ్స్. కాకపోతే ఈవెన్ దో ఫాస్టర్ దెన్ DES అండ్ IDEA, ఇట్స్ 64-bit బ్లాక్ సైజ్ మేక్స్ ఇట్ వల్నరబుల్ టు సమ్ అటాక్స్ అనమాట. అండ్ దట్స్ ద రీజన్ ఇట్ ఈస్ వల్నరబుల్ టు అటాక్స్. సో 3 points వీ హ్యావ్ టు రిమెంబర్. నెంబర్ 1 సిమెట్రిక్ కీ. నెక్స్ట్ సిమెట్రిక్ కీలోనే వేరియబుల్ లెంత్ కీ. దాని తర్వాత 64-bit సైఫర్, ఫాస్ట్ అండ్ ఫ్రీ టు యాక్సెస్ వెన్ కంపేర్ టు DES అండ్ IDEA. అండ్ థర్డ్ వన్ వల్నరబుల్ టు అటాక్స్ బికాస్ ఆఫ్ ఇట్ 64-bit బ్లాక్ సైజ్. ఇప్పుడు ఫీచర్స్ ఇక్కడ నేర్చుకుంది. నౌ వీ హ్యావ్ టు రైట్ డౌన్ అండ్ జాట్ ఇట్ డౌన్ as ఫీచర్స్. నౌ టైప్. వాట్స్ ద టైప్? 64 సిమెట్రిక్ బ్లాక్ సైఫర్ కదా. దట్ ఈస్ encryption and decryption both requires a key. So block size is 64-bit. Key length is it can vary from 32-bit to 448-bit. And year it is born in it was invented discovered as in 1993. And there are 16 feastal rounds. Okay, so 16 feastal rounds are done in order to make sure that the ciphertext is complete what should I say, generated in such a form it is complex for the plain text to be generated from the CT. దాని తర్వాత స్ట్రక్చర్ ఫీస్టల్ నెట్వర్క్ అంటే యూఆర్ యూజింగ్ రౌండ్స్ 16 ఫీస్టల్ రౌండ్స్. స్పీడ్ అంటే ఫాస్టర్ దెన్ DES అండ్ IDEA లైక్ డేటా ఎన్క్రిప్షన్ స్టాండర్డ్ వాటి నుంచి కూడా ఇట్ ఇస్ మచ్ మోర్ ఫాస్టర్. అండ్ సెక్యూరిటీ ఇస్ మోడరేట్ సెక్యూరిటీ. సో హౌ టు రిమెంబర్ దిస్? యూ కెన్ రిమెంబర్ దిస్ లైక్ యూ కెన్ S cube, like what is a structure speed security, S cube, and after S you can see RTYBK. Okay, if you don't know all these things you can just from the introduction only you can write whatever you remember. S cube, that is speed, security, and structure you can write about the key size, or directly you can write about the 64-bit length, that is the block size, and what is the type and number of rounds, it is 16. Here even if you write or not write, that doesn't matter. So coming to the working principle, let's understand how this blowfish is working. So it is based on feastal cipher structure as I already said, and 16 rounds of encryption. So each round has remember this sentence is very much important. Each round has substitution and permutation using 6 XOR operations and S block lookups. In every single of the each of the 16 rounds, every round has S block lookups and XOR operations going on, and substitutions and permutations are going on. So in every round, substitution, permutation, S block lookups, and XOR operations, these 4 are going on. You'll remember this sentence. So coming to the main steps, first key generation, sub key generation has to be done, right? So key expansion, sub key generation, data encryption, and then we are having data decryption. So decryption, encryption, whatever you see, if they are completely reverse of each other. So let's understand how keys and sub keys are generated. So this algorithm creates 18 sub keys, and these 18 sub keys are called as P arrays. Okay, P arrays, 4 S boxes. Each box has a capability of 256 entries. Okay, now digits. Now let's understand. These P arrays are there, right? Digits of pi are used to first fill these arrays. Now digits of pi are used to fill like P1, P2, P3, P4, P5 up to P18. Now these digits of pi are used to fill those arrays. Now on the user key, that is the main key, which is of the length 32-bit or any bit up to 448, it is up to 448 is XOR with the P arrays. Okay, if you don't understand this, let's once see the diagram, you'll understand. Okay, I'll tell you. Just remember, key expansion means it creates 18 subkeys, and we are having 4 S boxes. Each S boxes can hold 256 entries. Okay, now this 18 subkeys, each one is called as one P array, like P array, P1 array, P2 array, P3 array up to P17. So P not array, like that. And now our main key is being XORed with this P array to P array. Okay, now let's understand data encryption. So 64-bit plain text is divided into 2 halves, 30 to 32. And here we are having, as I already said, 16 fetal rounds. I'll show you the diagram now. Let's understand. So let's see here what's happening. Here encryption, first I said 64-bit plain text, right? What did I say? There are 16 rounds, like from round 0, 1, 2, if you count till round 15, there will be 16 rounds, and after each round we are having one particular sub key, right? There are 18 keys created. 0 to 15 will become 16 and 17 18. So like that till P15 we will be writing, 17 18 will be jotted down here. Okay, we need not explain or write them. So first you write how to draw this diagram. 64-bit plain text, that is important, and 64-bit cipher text. In between what's happening is there are round 1, round 2, round 0, round 1, round 2, round I, dot up to round 15. After round 15 we will be having post-processing process or phenomenon. After this we can directly get cipher. Okay, now how are the PRAs integrated here? P0 for, that is, this is the sub key for round 1, round 0, P0 PRA for round 0, P1 for round 1, PI for round I, and P15 for round 15. Okay, in this way you can write the P0, P1, P2. Now in the same way, I'll show you the diagram, you'll understand. Decryption is just the reverse of it. So first 64-bit cipher text is given, and below the 64-bit plain text is given, and same round 0, round 1 till round 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, round 15. And what happening is, as I said, reverse, right? So this is starting from P0, P1, PI, like that. But here P17, P16, P15, P14, P13, P2, P1, P0. This P1, P0 are already integrated and we need not jot down. Post processing, and we are having 64-bit PT. So I hope you understood encryption and decryption properly. Now let's understand in this encryption, let's understand these rounds. Like what's happening here. The entire 64-bit plain text, right, is divided into 30 to 32. Now for each round we'll understand steps. This is the representation of the each round. So as I said, the entire plain text is divided into 30 to 32 bits on the left, 32 bits on the right. Now what happens is L is XORed with this L is like left half is XORed with the sub key from the P array. So left half is there, right, is XORed with what? With sub key, 32-bit sub key from the P array. Okay, it is from the P array, it is XORed into 32-bit sub key from the P array, and result is sent into the F function. It's correct, right? This is XORed with the P array sub key is XORed, and this result is sent into the F function. Okay, now output of the F function is XORed with R, that is the write, and swapper. Now after this F function, the output is XORed with the write. Correct, right? It is XORed with the write, and this output of this 32-bit XOR will be coming as 32-bit XL, and output of this 32-bit XL will be coming as 32-bit XOR. Okay, I hope you understood. It is being swapped. That's why we said F function output of function F function XOR with R. So again let's check in detail. 32-bit XL, 32-bit XR. Okay, now what's happening? 32-bit PI, that is the array, that is the sub key array, it is being XORed. The L, the left half is being XORed with that of the P array, and now the output is being sent through the design round function. The output of the function round function is being XORed with that of the right half, and it is swapped. That is, the output of right half is given to that of 32-bit XL, and the left half is given to that of 32-bit XOR. Okay, in this way 16 rounds work. Now coming to data decryption, as I already said, reverse of encryption. Here we are having, that is the sub keys. Sub keys are used are used from P18 to P1. As I said, P18, P17, P16, 0 up to 2, and 1 0. 1 0 need not be jotted down. Next example. For example, we are having hi world as a plain text, and the key we have given is ABC123. It is our user given key, right? So Blowfish algorithm prepares subkeys based on ABC 1, 2, 3. It prepares subkeys. Now, how many amount of subkeys are created? I said 18. 18 subkeys are created. These are called as P arrays. Okay. And now it splits the left half. So here let's count 1, 0, 1, 2, 3, 4, 5, 6, 7. That means 8 bits are there. Space also should be considered here. So high 1, 2, 3, 4. Including space, we are having 1, 2, 3, 4. Right? ORLD. So including space, ORLD will be having 4, 4. It depends on us, depending upon the amount, depending upon the bits in which the plain text is consecrated, we will divide into half. Okay. Now we are having 32 bits, right? What did I say? 1, 2, 3, 4. 4 here. 1, 2, 3, 4. Okay. 16 rounds are being run. As this diagram, let's take it down. That is, L is being XORed with that of the plain text to give, and the result is being sent into function. So L XOR with that of the sub key and the function. Okay. Now after this, the result of the function or the output from the function is XOR with that of R and swapped. So what's happening? F function, the output of the function is XOR with that of R and swapped. That's it. So after 16 rounds, final swap and XOR. Okay, what it's saying is, this function has 16 rounds, right? There are 16 rounds. After 16 rounds, the output is final swap and XOR. The XOR is done and final swap is given. Okay. Now we are checking in the advantages and disadvantages. It is a flexible key size. Without seeing, you can say flexible key size is important. It is faster and you can access it anywhere. That you need not free to use and fast and efficient. You have all the licenses. Data encryption. Once the key is set, data encryption is really fast. But the problem is, key has to be set. The key setup is not easy. The key setup is slow, and due to the 64-bit block size, it has so much of vulnerability and no built-in authentication or integrity check. There is no built-in authentication as such, checking if the person who is authenticating with the key is a genuine one or not. Anyone who has the key can have the access. Okay. So Blowfish, first important thing, most important, symmetric is important. So symmetric, variable length and 64-bit block size. Key is symmetric and variable length. So introduction, we will be having key features and working principle. We are having 3: key expansion, data encryption, data decryption, and then we are having the example of high world and advantage, disadvantage. These diagrams I told you how you need to write. You will understand. In F also we can completely have a deep diagram regarding the 4 S boxes, how they work. One thing I should say is, in F, since 32 bits is going inside, it will be divided into 4 X boxes such that each S box will have 4, like 4 S box, 8. So each S box will be having 8, 4 X boxes, right? So 32. Finally, we'll get 32. So I didn't check that diagram, or because it will be so deep and you have to write a lot in exam. So this is more than enough, I feel.